Hi, thank you, everybody. Michael and I founded IoT Ventures, and basically the focus for us is on designing and building end-to-end LoRaWAN solutions that deliver value and scale, and then we turn those into businesses, hence the ventures in the name. So we're going to talk today about one of those businesses. It's a business called HorseSafe, and we're going to sort of share our thoughts and challenges and some of the lessons that we've learned in putting this together. So we're going to cover a number of topics. I should push the button actually to get that going. To get started, we'll kick off with objectives, background and some challenges. Move on a little bit to the domain, where the value is for HorseSafe, the sort of things that we need to know and measure, and the work that we need to do to deliver the value. Then we'll talk a little bit about the solution, the platform that we build it on, and some of the lessons that we've learned. So what is HorseSafe? Effectively, it's our first consumer application. It's designed for people that own horses, who've spent a reasonable amount of money on buying their horse and spend a lot of money looking after their horse and love their horse a lot. And so they spend quite a lot of time worrying about how well their horse is and whether there are any issues. And if there are issues, how they can intervene early to prevent them becoming very costly and potentially deadly issues. So we developed a solution to address these problems. And to do that, we realised we had to sort of step into the unknown. We've had to go to areas where there hasn't been measurement before and where science has kind of stopped. So we need to step in there and try and solve some new problems and learn as we go. So we feel pretty well suited to this. That's our kind of genetics, really. We've got many years of systems integration and business transformation experience. We've got a couple of decades of managed care and getting health information onto mobile devices, so we sort of understand the idea of how to present clinical and health data. Between the founders and the owners of this business called HorseSafe, there's more than 100 years of horse ownership and veterinary science involved. And then as an IoT Ventures as a company, we've ended up building end-to-end solutions for monitoring the health and wellness of elderly people, monitoring the state of beehives and particularly whether or not they've been stolen, monitoring boats, whether they're sinking, whether their batteries are going flat, controlling irrigation and large-scale agricultural deployments, measuring kind of silo fill levels and supporting supply chain management for dairy farms, monitoring water safety and water scarcity and water availability in remote Pacific Islands and ensuring tools for managing drought and community water management, and getting further and further off the grid in terms of providing data back to people to help them do what they're doing. So at the moment we're monitoring more than 10,000 things and we're growing that sort of day by day. So we came at IoT from an end-to-end solution provider point of view from day one, which put us slightly out of kilter with the rest of the industry. So when we started talking to people 6 or 7 years ago, everybody was very focused on the criticality of engineering to deliver solutions. Our perspective, this blue line, was that there are a number of other dimensions that needed to be considered if you were going to get something that people will pay for and that will operate and succeed at scale. So some of the challenges that we came across were twofold, really. The first one was working out what the value is and how we could measure it. And then the second one is making sure that we actually could deliver it and that we were measuring the right things. And so if we drill into that in a little bit more detail, about 40% of our focus through this project that we've been doing for more than sort of 3.5 to 4 years now has been on what is the value proposition, how do we measure it, what are we recording, how are we getting the data for it, and then more than 40% of it has actually been spent on testing and confirming that what we were measuring is actually meaningful and to deliver on the value proposition. Only about 10%, actually 12% of the challenge relates to electronics and networks and the engineering technology. So I'm going to hand over to Michael, who's going to come and talk through a bit more detail about where we've got to.
Thanks, Matt. Thanks. So horses come in lots of different shapes and sizes. There's about 200 different breeds of horses, and there's about 60 million horses in the world. So if we want to get value, we really need to be able to have fit individually for those horses. They also live in a lot of different conditions. They live in stables, they live in mountains, they live in gullies and valleys. In different conditions, they'll have different behaviours. So in order to be able to meet all those different conditions, we need to be able to understand a lot about those individual horses. So scale means we need to be able to achieve as much of the population as possible, and the individuals have diverse measurements, and the value means we need to get the best fit for each individual. And that requires calibration and diagnostics, as we'll come on to. There's a few inconvenient facts about horses, and anybody who knows horses, they break things. Whenever they break things, there's a good chance they'll get injured, and those injuries can become fatal quite quickly. They can escape. They're smart animals. If they get on the road, they'll die, normally if they get hit by a car. They have very bad digestive systems, get conditions called colic, and if it's not treated within 24 hours, it may require a many $1,000 operation, or the horse will die. They have lots of problems with their feet and hooves. They get sick, they get cancer, they get infections. That horse is actually a horse of mine, got an infection. One day later it looks like that. If we don't catch it that day, the next day the horse is dead. Horse gets stuck. If you don't catch it, the horse is dead. This horse got drunk, walked into a swamp, didn't catch it in time, that horse died. So these things actually happen to horses. That happened. That's a horse that, using one of our devices, picked up 10 days ago, and they didn't realise it was foaling. That's the foal there. It's at night. That's why the image is such poor quality. And fortunately, that was okay. And they just get anxious because they're herd animals, and they're easily scared by things like fireworks. If we want to produce value, we need to realise that there's a team involved in looking after a horse. He's not just the owner of the horse. He has a team associated with him. He's got probably a horse manager. He'll have grooms. They all want to be able to see what the horse is doing. There'll also be other people. There'll be the riders. There'll be specialised trainers who may want to know information. When an alert gets sent off, and I'll describe the alert in a little bit later, we need to ensure that the vet's called, or that the farrier's called, or that the person is called to repair the fence. So, and then we might need the dentist, or we might need the physio. So, and our system in due course will actually directly alert those people. At the moment, a horse owner, manager, groom needs to intermediate and gets the alert. But basically, if we have no action, there's no value in the solution. There's no point having a solution that just tells you something if you can't ensure the action. If you look at the types of questions we want to know, has it escaped, is it alarmed, has it got colic, is it injured, is it stuck, is it sick? In order to do that, we want to know things like, is it flank watching? Is it lip curling? Is it rolling too much? And if we want to know, is it further than the herd than it would normally be? Is it drinking less than normal? Is it walking less than normal? Is it moving less than normal? Is it chewing less than normal? By the way, that's lip curling, that's rolling, and that's flank watching. So we want to be able to detect those things amongst others. We need to know that information about individuals, so we need to understand about the individuals. There's no value if we don't have understanding. So we need to understand about the individuals, what their activity is, what their eating is, what their steps are, etc., and their stress levels. And so we monitor through some intermediate measurements a whole lot of those things. We also need to understand what the variance is, and we need to understand that variance by period. So if you think about something simple, this is an article for the Guardian. It says there's 3,967 steps a day is now the new magic number, is how many steps we're all meant to take a day. But the real point is, if I said to you, how many times do you roll each night? Because if I'm monitoring your rolling and I want to know you've got indigestion, what's the number? And the real answer is you don't know how many times you roll each night, and we don't know how many times all the horses roll. But if we don't know that, we can't detect what's abnormal. About the population, we want to know, how does it vary by population? We want to know how it varies by period, by condition, by season, by hour, by month. So we want to know, if we looked, we want to know how many times, what the steps are, what the eating pattern is, so that we can detect abnormality. So that's what the problem we're trying to solve. Why LoRaWAN? Because we need a device that never runs out of power. I can tell you that if you want to replace the battery on those horses, it's going to take you a while. That's not easy. Horses are often in conditions and states where replacing the battery, or in fact replacing the device, is extremely problematic. We need to be able to fill in coverage gaps, and people will tell you that the LoRaWAN's got good coverage, and by and large it does. This is a coverage map not of LoRaWAN, this is the cell phone coverage of New Zealand and the wide areas where they don't have coverage. And the reason they don't have coverage is that it's not economic, there's not sufficient volume to put coverage in for them. This is a map of my farm. The wide areas show where I don't have cell phone coverage. This farm is 20 kilometres from the centre of the city. This is a 400-metre tower that's in the centre of the city. It picks up a gateway 40 kilometres away, yet it doesn't pick up and didn't work in our office, which was 4 kilometres away, just because there's a shadow of a mountain in the way. So we need to be able to fill in coverage. Long range makes that viable. Unlicensed spectrum makes it legal. Relays also will help, and if we need to, we know we can go to satellites. We need a bidirectional protocol, because we need to be able to see and get diagnostics and readings, and we need to be able to do calibration. And it's cost effective, partly because you're not locked in. If I can own my own gateway if I want to, if I've got 50 horses, and I can run my own network server if I want to, so I can drop the cost down. So those are the kind of reasons we need LoRa. So LoRaWAN is fit for purpose for the sorts of things we're doing. If we look at the value chain, we need to be able to sense the information on the horse. That's a horse with a monitor on it. That's a test monitor and test harness. We have some rules on the device. We need to be able to connect it via a gateway, send it to the LoRaWAN, record the information, present the information perhaps to somebody. Then we need to be able to learn, so we find out what's normal. Then we need to evaluate the normal by hour, by day, by horse, by condition. Then we need to perform an alert, and if necessary alert the user, and then they need to act and get somebody involved. So that's the end-to-end chain. When we look at the challenges in that, there is a reasonable amount of challenges in knowing what the person actually wants to know, what the value is that they seek. There's a little bit of challenge in the sensing. There's no real challenge in the network or the gateways of communication from our perspective. We don't see that as a particularly difficult area anymore. It was 7 years ago when we started, but it's not anymore. There's a huge amount of effort in defining the on-device rules and doing the field testing for those rules to say, if the horse rolls 50 times, how many times are we picking the roll up? Or eating, or steps, or anything else that we're sensing. There's a lot. Presenting the data, dashboards and things like that doesn't seem to be very challenging. Recording the information, not very challenging. Learning is challenging, and learning what's normal, and then evaluating it's difficult. We have a slightly different view on devices than a lot of people. This device will get the device on the left will get a stone from a horse's shoe, and the device on the right will get a stone from a horse's shoe. The device on the left is 2 orders of magnitude more expensive and not very good at the job. The device on the right is €3 and excellent at the job. We think that the devices for optimised solutions need to look much more like the device on the right than the device on the left, if we want to be able to actually deliver value at optimised value. We looked at different sizes of device. We built a proof of concept device and then a pilot device. I won't go into the details of the device, but it's on the slides. It's got an accelerometer and it's got all the normal things that a device has. The blue things are part of our firmware framework, and the white things are physical components. And these are the messages that the firmware sends. They send different messages on activity, condition, and an urgent message. There's different frequencies that we need the information at. Then there's a whole series of messages to do with diagnostics and calibration, and there's a message to do with status, energy management, and configuration. Even the harness took about 3 months to work. We looked at device horizontally mounted, vertically mounted, what the horses will do with the device, with the harness. You'll see it in their mouth, around their ear, pulled off by a foal, and we finally, how they'll break the devices. And these devices, the harness for this, the target price point's about $10 US, because we need the device to be weak enough so that if the horse gets stuck on it, that the harness will break. And it will be disposable so that the horse doesn't get injured. So there are quite a lot of kind of challenges just getting an optimized device. We built it on top of an AWS serverless cloud platform, and our platform's completely serverless. If you look at a typical IoT business on the right-hand side, it'll have a help desk, social media, website, office systems, e-commerce, inventory, etc. And the IoT system's just one of those things. The platform we've got, which we're open sourcing, as I say, is entirely optimized for LoRaWAN and AWS, because we don't believe that if you pick multiple protocols and pick multiple platforms, you'll only ever get a lowest common denominator result. And it does all of the basic things like customer management, user management, rules management, message management out of the box, and it also manages multiple networks, so it'll produce, you'll see lots of network protocols, network dashboards. It will support, we use a range of different gateways, we use a range of different network application servers. It'll present a consistent view of all of that information, and it'll do analytics, and it'll do time series bucketing, and it'll do property management and coverage management. Again, it'll do coverage management at fine grain for multiple devices and multiple networks and multiple gateways. It's got an out-of-the-box UI with a few bits on it, and it uses Lambdas and Fargate at all the serverless technology for the logic, and it uses serverless, the AWS time stream, Dynamo and S3 for the data level. It does obviously ingestion and egestion using Lambdas, and it does notification and escalation, because when we send a message to somebody saying your horse is sick, or your horse needs treatment, we need to know that you've done something about it, and if you haven't done something about it, who we escalate it to, how we manage the escalation, with what time sensitivity, etc. So if somebody sends me a message now, my horse is sick, I'm in Tokyo, my horse is at 20,000 kilometres away, somebody else needs to do something about it. And obviously, if you want a system that will scale and you want it to be operational, because we see lots of these systems that are built, but will they actually scale up? Will they scale up? Will they provide the logging, the auditing, and all the other things that we know are necessary for large-scale systems with lots of users? The science, we induce the behaviour, we measure the systems, we get some records, we create a decision tree. Unfortunately, we have to decrypt the decision tree, but that's another issue. The vendor won't tell us the format of the byte array on the decision tree. We then adapt it for various levels of uncertainty, and we produce a final decision tree. That decision tree then is what lives on the device. Now the question is, if somebody says to you, well, my horse is not picking up rolls for my horse because my horse is old or fat or tall or short or whatever your horse is, we need to be able to look at how can we actually diagnose that and tune the rules for every horse. So what we do is, as I said, we've diagnosed it, so we can take the decision tree. We know the byte locations of the different nodes in the decision tree, which use features on the accelerometer, like peak to peak, or zero crossing, or mean, or energy. And then we can get the person to induce the behaviour, record it on their mobile phone, so we can time, so we know when the behaviour is happening at a time sense. Then we can ask we've got a special downlink that'll ask the device to go into diagnostic mode. In diagnostic mode, it'll send, obviously with LoRaWAN, you can't send, this device is sampling at 25 hertz, and it's sampling 100 different features. You can't send that back over LoRaWAN, so you have to pick one feature for a short period of time, send that back. We then get that back. That's actually a view in one of our dashboards. Then we can revise the threshold, update the thing, recalibrate the device with a single byte change on the device, which you can easily send over LoRaWAN and recalibrate it. We also need it to never run out of batteries. As I said, replacing batteries like this is difficult, so we've done a lot of detailed analysis of the consumption, how the energy is consumed, and also how it's used. And that's actually the device running out of power over 5 days, because we consume as much energy as we can. And based on the usage, we've got some capabilities to change the energy consumption. However, in an emergency, the horse is out on the road, it's going to get run over, we'll consume all the energy because we don't care if we save the horse by consuming all the energy and in fact also exceeding the duty cycle that's traditionally required for LoRaWAN, but we save the horse's life. We'll throw away the device after that if we have to, we don't care. But because we use fingerprinting, our back-end system does fingerprinting. I don't have time to explain what I mean by that, but we can tell where a horse isn't. So we can tell that a horse can't escape because we know, based on fingerprinting, approximately where it is, or more importantly, where it isn't. And then we can switch off the GPS because to conserve power, so we can continually maintain battery life. I'll pass over to Matt to discuss the network in his remaining 1 minute.
LoRaWAN is, and in this sort of solution we have a number of different options where the consumer is able to buy their own base station and put that in for themselves and use their own network server. That they may use a public network and or they may use a network that we provide linked to a network server that we provide, and we might provide them with the base station as well. But the solution needs to be able to operate, including the coverage management and all of those details that Michael has gone through across that hybrid kind of system, as well as we start to fill in gaps with relays and satellites. So being able to manage that is a critical part of the solution. So as you can imagine, putting a solution together like this requires a fairly diverse team full of people. We focus on the value and design. We've got device and firmware engineers, network and operations people, systems people, and of course people that are out there in the real world doing testing and making sure those rules are actually working. So it takes a village to raise a horse solution, and all other solutions, to be honest. So really kind of where we're up to, or what we've learned from this, is that we still agree that engineering is important, and we're certainly very confident that knowing what the value proposition is and what the value is for solutions is really essential. But as Michael described, being able to do diagnosis and calibration on the device and being able to get that raw data back and be able to update rules remotely and then push that back down over LoRa, that is a key feature and one that we've built into our core platform, and basically are able to take the learnings from that and put it into the next set of solutions that we build. So that is where we're at. That's where we've got to with HorseSafe. Thank you very much. We will be happy to take questions at the end. Thank you.